Hi, did you know EDEXCEL made practice papers? Well, they do, and they're a fantastic resource. They are full sets, papers 1, 2, and 3, and 80 marks on each. So, how many have they actually made? Loads. I mean, loads. There are 144. I don't think anybody would need that many. Anyway, I am making it my mission to do worked solutions for as many as I can. Obviously, the goal is all 144. I do work full time though, so I'm going to be creating them and pushing them out as quickly as I can. So watch the channel because new videos are going to land all the time. Now, to use the papers, I would recommend downloading them, sitting quietly, cracking on with it, and then coming back to do the marking. You've got all the solutions with walkthrough examples. So if anything's gone wrong and you need to see the steps and the methods, it's all going to be there for you. Now, for grade boundaries on the end screen, I've provided some percentages as guide only. No one knows what the grade boundaries will be ever. Anyone telling you are really just trying to give you a guide, and mine is no different. I have gone for the highest percentages we've seen so that we are reducing our risks, but it gives you a goal. It gives you something to head for. And I think that is really, really useful. So once you've got your score, check out the end screen, and that will also give you an idea of your grade. Now, if you're really struggling, if you're finding that you're sitting down to do the papers and they're not going very well, but you like the way that I explain and walk through the questions, then I do have some courses that are available. They are in the description below, so you can just click on that link. If you are somebody that wants to be studying and gaining the higher grades, my grade 6 course is currently free here on the channel. So do go and check that out. The course is designed to help you develop your critical thinking skills. So whilst it's all labeled up as grade 6, because we use a lot of those topics to help us, actually what you're going to really get from that is those topics, but the critical skills that you need. Okay, well, good luck with your studies. This will make a great addition to your revision. If you like what we're doing, please hit that like and subscribe button. That'll hopefully push the video out to more people and more people can benefit from it. Obviously, comments are great. So yeah, just good luck. Revising for a GCSE maths, it's going to be tough. So I wish you well. Okay, so the gradient of the line is the number that is always in front of the x. So the gradient would be 4. And then the y-intercept is the number that basically is not attached to an x. So the line is crossing at 7 on the y-axis. Okay, there are various methods for working out fractions. I'm going to do the smashed window. It may be different to your method. First thing, however, is that we need to get rid of the mixed numbers. We don't have methods for mixed numbers. We have methods for fractions, and that's really important to remember. So the denominator is multiplied to the whole number, and then the numerator is added on. So 8 times 3 is 24, plus the 1 is 25. So I've got 25 over 8, take away 3 times 1 is 3, plus 2 is 5 over 3. Now I'm going to go into my smashed window. And I've put my first fraction along the top and my second down the side. I'm going to multiply in. And then just remind yourself, it's a takeaway. It's so easy to just add. 35 over 24 is our final answer. It doesn't ask us to give our answer as a mixed number, so you don't need to do that. For smashed window, if you've not seen it before, you always add or take on that diagonal, and the number in the corner here is always your denominator. Okay, so this was a really tricky question, and it is hard. There's no easy way to get around this other than to do the maths the long way. So I'm going to just do my calculator method and work it through by hand. Okay, so I'm trying to work out the greatest number of shortbread biscuits I can make with the ingredients that I have. So I'm going to need to work out the maximum that butter can make me, and then caster sugar, and then flour. The fact that I have to help me with the butter is that 120 grams is going to make 8 biscuits. So I pop that into my grid. My fact is always at the top, side by side. The information that I've got for butter is that I have 330 grams, not 120. Okay, so I want this to work for me, being non-calculator. I know that I always divide by the number in the corner here. I can divide 330 by the 120 or the 8 by the 120. And I'm going to set the 330 divided by the 120 up because obviously they both have that 0, which means I can straight away cancel this down to 33 over 12. And I times through by the 8. So I'm going to times through by the 8 first. And then I'm going to divide through by the 12. Now, at this stage, I do have some left over. 12s into 14 go 1, remainder 2. But I'm trying to work out the greatest number of shortbread. So it doesn't matter that it carries on and there's a little bit more I can make of a biscuit. I just know that butter is going to make me a maximum of 21. And that's all I need to know. So I can stop there. So that's my butter done. And I'm going to repeat the process with the sugar. So the fact is that 8 biscuits can be made from 60, and I've got 200. I'm going to set my 200 divided by 60. Now, with this one, I can cancel through by 10, but I can also half. I can also divide by 2 to get me an even simpler fraction. So 10 over 3 times 8. So 10 times 8 is 80. And then I just need to divide that through by my 3. So I can get a total of 26. Now that doesn't matter that that's greater. I don't have enough butter to make 26. So 21 at the moment is the greatest number that I can make. But I've got to check in with the flour next. So my fact is that 8 shortbreads can be made from 180. I've got 450. Setting it up in exactly the same way, dividing through by 10. And then I can see that 45 and 18 is in the 9 times table. And that takes me to some very straightforward, nice, easy, low numbers. You might notice that they're in the 3 and divide by 3 and then realize you can cancel again. It doesn't really matter. But if you can cancel the fraction, you're making the maths way easier for yourself. So 5/8 are 40. Divide that through by 2 and 20. Now that is smaller than the amount I could get from my butter. So this is the greatest amount that I can make. So 20 would go on the dotted line. And I've got all the working as requested. It isn't the only way, but I couldn't find for me and for the way that my students work a better way in. So it was a lot of work. Okay, so this is another really tough non-calculator question. The normal approach that we take with percentage questions on non-calculators is to find 10% and manipulate it. If I do that here with rail tickets, if I started off finding 10% and then halving for 5% and halving for 2.5%, I'm not getting to the 2.25 that I want. And actually, the way that this is worded is really important for me to clock as well. 2.25% of the ticket price is something that I can write mathematically. 2.25, so that number, and then percent means out of 100. So that's the percentage sign written mathematically of means times. So that's my of. And then, of course, my ticket price is 60. So that entire sentence can actually be written mathematically. I've got a fraction to multiply into a whole number. If I wanted to, I could take that whole number and put it over 1 so that I could see it almost as multiplying fractions. And then it's a just do it question. If we are confident about multiplying fractions, we will know that we can cancel down denominators and opposite numerators. If we're not confident about that, then we would have to do 2.25 times 60 and then divide the answer by 100. But this will make the numbers work a little bit more in our favor. I could actually divide by 20 and cancel that right down to 3. And obviously, what I do to the top, I must do to the bottom. And that would give me 5. That completely changes what I'm looking at here. I've now got 2.25 over 5 times 3 over 1. 2.25 times 3 is 6.75. Now, if you can't see that it would be 6.75, you can just put it on top of each other and add it up. And 5 times 1 is 5. So I now need to work out how many 5s are in 6.75. So that's going to go into my bus shelter. So 6.75 divided by 5. 5s into 6 go 1, carry the 1, but there is a point, so bring it up. Then it goes 3, remainder 2, and 5. So 2.25% of the ticket price is £1.35. There's also that booking fee of 80 pence. So 1.35, add on the 80, and we've got a final price of 2.15. Now we're going to do cheap trains. They're charging 1.5% of ticket price. So here we go again. 1.5 over 100 times 60, put it over 1, cancel it through. 3 1.5s is 4.5, and we're going to divide that by 5. So 5s into 4 don't go, carry the 4, put that point up though, and then 5s into 45 go 9. So this would be money-wise 0.90. Their booking fee is £1.90. So you add that up and you get £2.80. So the charges would be your ticket price 60 plus £2.15 here or £2.80 here. So we want to go with rail tickets. Okay, so we're being asked to draw a frequency polygon to show the information. Frequency polygon is just a fancy language for a straight line graph. So basically, a straight line graph. To draw a straight line graph, we need coordinates. For this question, the coordinates come from the midpoint in this column and the frequency. So this row would be 520, and you would find your 520 and you would plot it on your graph. You would then work out all your coordinates, plot them, and draw your straight line. And when you've done that, it should look like this. Now, part B wants you to work out the total number of branches on the bush. So that's your total frequency. So you would just be adding your total frequency to get that answer. So 56. And then the modal class is the class with the biggest frequency, which is in the first row of a frequency of 20. So we would write for part C, 0, L, and your 10. Okay, we've got 3 circles and we've got information about the area. Now, I'm a big fan of transferring information into diagrams wherever possible. So the area of circle A is 200. The area of circle B is 10% larger. So 10% of 200 is 20. So that would be 220. And then area of circle C is 10% larger again. So we've got 220. So 10% divide by 10 gets you 22. Add that on, and you've got 242 for C. How much larger is the area of C than the area of A? So what we want to do here is the difference between the original. So almost like how you start a percentage change. So the difference is 42 over the original, which is 200. That is the difference, is a fraction. If we divide through by 2 and get it so it's over 100, then the difference is 21%. Okay, expand and simplify. So the expand stage is just to multiply out the brackets. And then the simplify is to bring those x's together and those y's together. So we've got 2x plus 4x, which is 6x, and 6y. And be really careful, make sure you're clocking that sign in front of the number. It's -4, take away 4. So 6 take 4 is 2. 2 is a positive number, so plus 2y. And then factorizing is doing the opposite. It's putting the brackets back in. So you're looking to see what is common in the terms. So in the numbers, 8 and 12 are both in the 4 times table. Now, you could say it's in the 2s as well, and you wouldn't be wrong, but you must always choose the highest times table. So that would be 4. P is common in both. So you pop your P down, and then you open up your bracket. I want to put something in here that when we multiply it by this on the outside, it will create 8p. So 4 times 2 creates the 8, and the single p is already on the outside, so we don't want to do any more than that. And then I'm going to need 3 to get the 12. The single p is already on the outside, but I need a q, so we attach that. And that is the expression factorized. Okay, so we're looking at a triangle. We've got expressions for the angles, and we're being asked to show that the triangle is an isosceles. To do that, we're going to need to know the value of x so that we can substitute it in and work out what these actual angles are. So it's an angle question. It's in a triangle. Angles in a triangle add up to 180. So these angles will add up and equal 180. So I've got 6 plus 4 plus 5 x's, which is 15x. And then I've got 2 plus 8, which is 10. Take away the 10, eliminates the numbers. So I'm just left with my 15x. So 15x is equal to 180. I need to divide through by 15 to work out what x is. So we need to set this up. 15s into 1 don't go. 15s into 18 go 1, remainder 3. And 15s into 30 go 2. So my x is equal to 12. Now all I need to do is work out each one of the angles. So this would be 4 times 12 plus 8. I'm going to do the same here. And finally do the same here. So I can see that I've got 2 angles the same. So I have shown that the triangle is isosceles. If I want to, I can just make that statement as well. So it's really communicated well to my examiner. Okay, so we need to find the highest common factor of 30 and 42. Now, these numbers are quite low. They're in tables that we have learned and understand, and actually just finding the factors will help you find that highest common factor. I am going to demonstrate a slightly different method just to remind you that it's available to you. Obviously, it would work here, probably more work than you need to do if I'm honest, but equally, I just want to take the opportunity to remind you so that if the numbers weren't as kind, maybe it was to find the highest common factor of 42 and 190. I don't know, I'm making it up now. But if they were numbers that were a little bit trickier, then this method really would work nicely. So what we're going to do is just find the prime factors, which doesn't take very long at all. And then we're going to pop them into a Venn diagram. 2 and 3 are in both. So that leaves me 5 and 7. The highest common factor is the middle section, 2 times 3, which is 6. If you're confident with this, I actually don't think it takes any longer than finding all the factors, but that is one way to do it. Now we need to find the lowest common multiple of 30 and 45. 45 is a different number, so don't think you're working with the same Venn diagram. You could work it out using the Venn diagram, and then it is all the numbers that you multiply for the answer, or you can just do lists. If you choose to do the list way, I would always list out the larger of the two. So what we're doing is we're going to write some of the times table. So 45 and then 90. And before I carry on, I'm going to always consider, could the number I've written be in the times table of the second given number? And I can see straight away it will be. So this one really is very, very simple. 90 is the first number to come up in both times table and therefore is the lowest common multiple. Okay, so we've got a diagram and we've got a lot of information to digest. So you read through and take in as much information as you can to consider the problem. So we've got a solid prism. The cross section is a trapezium, which we can see. We've been given the information that we can see in the diagram. So we just want to double check that they're not giving us anything in addition, because if there was more information here than in the diagram itself, we'd want to add it. But really, this is just a worded version of what we can see. So we don't have to worry too much about this. It then says the density of the metal is 5 grams per centimeter cubed. So I've read a keyword here, density, and it's asking me to calculate the mass. So I now know that this is going to be a mass density volume. So I'm just going to quickly write that down so I don't lose sight of my formula. M is on top, your V and your D can go in any order you like. I've got to calculate the mass, which means I would be doing volume times the density. They've told me the density, so I know I've got that. The volume is actually my problem. So whilst mass is the question they want me to answer, my problem is volume to start off with. The volume is the cross section or the front face, and in this case, the trapezium multiplied by the third length. Trapezium is A plus B, that's your parallel sides, multiplied by the height and divided by 2, and that would be times by 20. So that's the maths we've got to do. So I can see that 8 plus 12 is 20, times that through by 6 to get the 120, then half it to get the 60. The 60 is multiplied by the 20 to get 1200. So I can go back to my formula. My volume is 1200. My density was 5. I multiply that through and I get 6,000. Now it says, give your answer in kilograms. If you look at our density, you can see that we were given grams. That means our mass is grams. We will just need to divide by 1,000 to get this into kilograms as requested. Okay, anything to the 0 is 1. We've then got 49, and then it's to the negative half. The denominator is a root. It's 2, so it's a square root, which gives us 7. The numerator is a power, but anything raised to the power 1 is itself. Now, the negative means reciprocal. It doesn't mean that you're going to get a negative number. To perform a reciprocal on a number, you need to flip it. The best way to do a whole number is to see it as a fraction to make that flipping really easy to complete. It's just going to go upside down on itself, and we've got 1/7. Now, we're being told in part C to write as a power of 2. None of these numbers are written with a base of 2. So when it says write as a power of 2, what that means is you will, in your final answer, have base 2 with some sort of power on the top. So what we are going to do is change all of those numbers into base 2. 4 could be written as 2 squared. 8 could be written as 2 cubed. Now, 16 is a little bit trickier. We've got 2 to the 4 for the 16, but that is being raised to the cube, to the 3. So now we've got everything written out, we can start the process. When you multiply, you add the powers. So you've got 2 to the 5. And when you've got a power to a power, you multiply the powers. So that's going to give us 2 to the 12. We've now got the division in the fraction. When you divide powers, you take them away. So 5 take away 12 is -7, and that would be our final answer, 2 to the power of -7. Quite a tricky one, that one. Okay, we've got a probability question. We've got to work out the probability that he takes at least one yellow counter. So the first thing I'm going to do is draw a tree diagram for all the outcomes so that I can start to build a picture and work out how I'm going to answer this question. So I've done the first branch and I've put my probabilities on. I'm now going to just build the branches only and have a little look at the outcomes. Now I've got to work out the probability that he takes at least one yellow. This pathway here, red, red, is not what we want, nor is the red, blue. But here we've got at least one yellow. Nope, nope, yep. And then we've got all these. Even this last one where it is yellow, yellow, that is at least one yellow, so we include it. Now, I'm always looking for ways to be as efficient as I can with my maths. So I've got 2 choices now. I can either work out the fractions that go on these, work out all of the multiplications that creates, add them up and get my answer. Or I can do the ones I don't want and take it away from 1. I am going to do it that way because actually there is less work to do. I've only got 4 that I don't want, as opposed to doing 6 that I do. Now, if a counter has been taken, so if I've started here and gone along here, I've taken a red one out. So my next red will be 1 less out of a total that is 1 less. The blues, I've still got all of those out of the 8. I'm not bothering to put the fraction on the yellow because I'm not going to do that piece of maths. If I've travelled and taken a blue, then I'm going to only have 1 blue left out of 8. And I'm going to have all my reds out of 8 left. So that's as much of the diagram as I need. You multiply across, so you've got 4/9 times 3/8, and you've got 4/9 times 2/8, and I'm going to build the rest of them as well. And you just work those out, and then you just add those all together to get a total of 30 out of 72. Now that's the probability I don't want, remember. The probability that I do want is 1 minus this, which is 42 out of 72. So I'm just trying to demonstrate a more efficient way of maybe thinking about this. If you're more comfortable just working out the ones you actually want and adding those together, then that is going to get you the answer. There's no right or wrong here. You must be doing the way that feels natural to you. Okay, so we need to simplify fully. Now we're looking at quadratics. So if you were looking at this question, you thought, I haven't got a clue. I haven't got a clue what I'm doing. I really want you to have that confidence to say, what am I looking at? What do I know? You are looking at quadratics. What do you know? Well, they're expressions. There's no equal sign. I'm not trying to solve this. The only thing I know is that I can change the way a quadratic looks. If it's given to me in this form, I can factorize it and express it in the kind of double bracket form. Well, that would be the right thing to do. And that is what we are going to do here. We are going to get brackets on the top and we're going to get brackets on the bottom. So let's look at this. We're going to do the bottom first because actually this one is the easier one. Usually we would say if there's two terms, it's one bracket, but this is the exception to the rule. If you tried to put it in one bracket, you would be looking at it and go, right, what's common? What can come out? Well, X isn't in both, so X can't come outside, and there isn't a number, so I don't have a times table that's common to come out. So as soon as you try that, you'll notice it fails very quickly. This is the difference of two squares. So this is just a square number that we need to root. And then you've got your X plus 3 and X minus 3, which are your results for square rooting 9. Okay, so now we're going to work on the numerator. We've got 2x squared minus 7x plus 3. So we've got our two brackets. We drop the 2x. We can see it starts negative, so it's going to be neg. And then we'll multiply the first and the last. What multiplies to make 6? 1 and 6, 2 and 3. But I do want to make 7. I can't get a 7 out of that combo. It is the 1 and the 6. And I can just throw that in. And it's as simple as that. Knowing the little trick with the negative here just takes away a lot of the hard work. And if you haven't seen this method before and you're liking what you've seen so far, then click the link to the how-to video, which really explains it in detail. Because we have multiplied to get this 6, we are now going to have to cancel and divide it back down. If I look at these individually, I can see that there is the 2 times table within these two numbers. Here, there's nothing I can do to cancel it any further. So if I divide this one by 2, I would get x minus 3. So I've got 2x minus 1 and x minus 3. My x minus 3's will cancel out to give a final answer of 2x minus 1 over x plus 3. You can leave it like that. You can put the brackets in. It makes no difference. That is your final answer. Okay, next question is a thirds question. It is a double bracket. So really, we would just be using whatever method we have for expanding two brackets. So I'm going to use Crab's Claw. 2 times 2 is 4. 2 times negative root 3 would be negative 2 root 3. And then we've got plus 2 root 3 and negative. Now, this is just 3. We're doing root 3 times root 3, which is basically root 3 squared. So these cancel out. The middle section is cancelling out. We've got minus 2 root 3 plus 2 root 3. So really all we've got is 4 minus 3 to do, which is equal to 1. Okay, we have a vectors question. We're being told that OM is M. So if this distance from here to here is the vector M, then OA will be 2M. And the same thing is happening with my OB. I know that ON is N, so OB is going to be 2N. Now I've got to show that they're parallel, so let's pop that line on. It's parallel with AB, and I'm going to need both of these. So we're going to do MN first. So MN is found by moving from M to O and then O to N. M to O is minus M, and then O to N is plus N. You could leave it like that, or you could rearrange it just so that the negative isn't at the beginning. And then we're going to do the same for AB. Now, AO is the opposite direction, so it's minus 2M. And again, you can just rearrange that so that the negative isn't first, although you wouldn't have to. Now, AB will also factorize. And you can now see how MN and NM is in both vectors. AB is just twice as long. So we can make that statement to finish it off. But that factorizing is the key thing that you're looking to do in vectors whenever you're trying to find a parallel line. Okay, circle theorems. We're being asked to find the size of angle ABC, which is this angle here. It needs to be in terms of y, so we're not trying to find an actual value. It's just going to be an expression in terms of y. And we've been given this angle kind of to get us started. So the first one that we can work out is this one here. So ADC is equal to a half of y. Now it says give reasons for each stage. So our reason is the angle at the circumference is half the angle at the center. Now that I've got that, I want to use it to help me find B, because these two angles are inside a cyclic quad. And the opposite angles of cyclic quads add to 180. So I now know that my angle ABC is 180, take away half y. And you can leave it with the half against the y, or you can incorporate it so that it's 180 y over 2. So 180 minus y over 2. Either works. Okay, we've got a sketch. It's being referred to as y equals f of x. There is a minimum point that we can see in the diagram, and we have to write down the coordinates of the minimum point of the curve with the equation, and it's our function of x with -2 in with the x. And this is how I do transformation. So this is all about the change in the graph that's been affected by that addition to the function, which in this case is a -2. Now, when it's in with the x as opposed to away from the x, it's the x coordinate that gets affected. So it's just my x coordinate that's going to get affected, and it's always affected in the opposite sign. So I've got a -2. So it's going to, instead of moving it back 2 places, it's going to move it forward 2 places. So the coordinate was 3 minus 4. I'm going to be adding 2 to the x coordinate, and that is going to give me the answer 5 minus 4. Okay, so in this question, we have the x coordinate being affected, but we have this which is outside or away from the x, which affects the y coordinate. And when your y coordinate is being affected, it is exactly how you see it. So you do what you see. So for this one, our minimum point was 3 minus 4. We're going to be taking away 5 for the movement on the x coordinate. And then we're going to be adding 6 for the movement on the y coordinate. And that would give us -2, 2 as a final result. Okay, so we need to prove that triangle ABE is similar to triangle DBC. Now, we've obviously got these parallel lines that are going to play a really big part here, okay? So the first thing we can say is that these two angles are equal because they are vertically opposite. We're then going to use our alternate angles to show that these two are also equal. And then you've got a couple of ways of describing these ones. You can use your alternate angle again. That's a nice simple way to do it. Or it's angles in triangles that up to 180. And obviously each one of these triangles is taking away the same value because it's got the same angles. I'm going to go for alternate angles because it's just going to be easier to communicate. So I've written down all my reasons for why my angles are equal. The triangles have the exact same angles inside, so they are similar with the AAA abbreviation. Okay, we are being told that the exact value of sine 60 is √3/2. And then using this information and the graph that we've been given, we can write down the exact value of sine 120. How do we do this? It's all in the symmetry, okay? If we consider 60, I don't know, being roughly here, let's say, that's my 60 degrees. I am 60 away from the 0. If I come in from the 180, 60, I will be at 120. So I will be at exactly the same place on the y-axis. So for sine 120, it will be √3/2 again. Okay, so this one's a little strange because it's just a repeat. So it's a typo, it's an error. And we've seen this a couple of times now on these practice papers. And yeah, I think it is just where they are not processed in the same way as a real GCSE exam paper is. So they're not really checked, triple checked, etc., etc. So I looked at the mark scheme, and the mark scheme was giving the answer as minus √3/2. Now, minus √3/2 is going to be obviously around here, which would cut it. And again, it's all in the symmetry. So this would have been 60 away, so 240. And this one would have been 300. So it was probably going to ask for sine 240, I think. But obviously I don't know because I am not psychic. Okay, so for this question, I've got a top tip for you. We have got to transform the graph. And we can see that it's in with the x. And we spoke about this earlier. So it's the x coordinate that's going to shift in the opposite direction. So it's got to move 45 degrees left or backwards. Now, don't overthink this. You have tracing paper in your exam. So all you have to do, in fact, I will do it as well. Let me get this small enough. All you have to actually do is trace the shape, and then you can take your tracing paper and you can put it where it was originally, and then you can just do that 45 shift. That shows you where it needs to be, and that would be your answer. Okay, we've got to prove algebraically that the difference between the squares of any two consecutive numbers is equal to the sum of these two integers. Proof questions are always such a mouthful, so you really need to try and break it down a little bit. One of the ways to get a feel for it is to just write it numerically. Okay, now that's not a proof. It's not going to get you any marks, but what it does is it gets you a kind of handle on the problem. So it's the difference between the squares of any two consecutive integers. So let's say we've got 3 squared minus 2 squared. These are consecutive integers. It's the difference between them, and we've squared them as well. And that's going to be equal to the sum of these two integers. So the sum of 3 and 2. So that's what we are going to write algebraically. So first of all, we need to write our consecutive numbers. So you would have n and then n plus 1. Now, n plus 1 is the bigger of the two, so I want to write that one first. And obviously it's squared, minus n, and that's going to equal n plus 1 plus n. I'm just going to concentrate on my left-hand side to start off with because there's a lot going on there. First thing we need to do is expand this bracket, which is going to give us n squared plus 2n plus 1. And then we've got our n squared to take away. Now, n squared take n squared means it's eliminated, it's gone. We've just got our 2n plus 1 left. And then if we tidy up this side, bring it down, we've got n plus 1 plus n, which is going to give us 2n plus 1. And there's the proof that they are equal to each other. Okay, our last question, and it is a biggie. So there's quite a lot happening for our 4 marks. We're being asked to sketch the graph of the function minus x squared minus 3x plus 5. So first thing we want to do is think about what that tells us. Before we start working on the algebra itself, what are we looking at? What do we know? Well, we know it's a quadratic and it's got a negative in front of the x squared, which means that it is going to have that negative gradient. So rather than the smiley face, we're going to have that sad face. We also know that it's going to cross the y-axis at positive 5. So I can make a start on my sketch literally straight away. So I'm going to put in my axes. I know that it's going to be crossing at 5 and that it's going to have that negative gradient. I'm going to mark on the first coordinate. So what I now have to do is work out this turning point, and I have to work out these coordinates here. Now, turning point is the key word. That tells us that we're going to be completing the square. So we've got minus x squared minus 3x plus 5. But this negative, we really want to factor that out so that it doesn't get in our way. So we're going to factor that out, which causes a switch on all these other signs. And then we're going to start completing the square. You halve that second term. That's all squared. Now, I want to make negative 5. I don't want to lose sight of that. This here, if I was to crab's claw it, I would end up, well, if we just take that as 1.5 times 1.5, that would give us 2.25. So this gives me 2.25, but I want to be at negative 5. So in order to get to negative 5, I would need to take away 7.25. So my final answer is going to be, and then we've got our x plus, might as well keep it all in decimals. So the turning point, the x coordinate is in with the x and it's always the opposite sign. For the y, we do need to be really careful and not forget about this. We must make sure that we multiply or see that these two negatives are going to make a positive, and that is going to give us 7.25. It would impact this if we were to expand it, but we're not expanding it at this stage, so that works. That is fine. That is our turning point. And it also makes sense for the sketch that we've got. It is going to be a negative x coordinate and a positive y. So I can mark that onto my diagram now. Okay, so you could use your completed square form to go on and solve it as well. I'm actually going to do it though using the quadratic formula. I just feel like because of the extra negatives and things, this might be an easier way and a less confusing way. Just don't need to worry about the negatives as much. So we're going to just substitute all our values into the quadratic formula. Tidy it all up. And then this will split in 2. And we're done. those will be the coordinates that we use. Now, obviously, we've got to make sure we get them the right way round. So this one will give us a positive result, which will give us our coordinate for here. And this one with the negative will just be for this coordinate here. So we're going to mark that on, and that will be us finished. Okay, a big question. I did warn you. Hopefully, I've explained it well and I've shown all the techniques that you could apply to this type of question. If you're going on to study A level, then this is the type of stuff we want you to be really, really good at. Okay, hopefully you have found these worked solutions useful. Please join us on the additional papers that we're going to be making. If you like what we're doing, then hit that like and subscribe button.